Welcome, dear students. So today we are going to discuss part 2, coagulation, mixing and flocculation. In the part 1 lecture, we discussed what is a coagulant, what are the different types of coagulants, the comparison among the types of coagulants, as well as the different methods of feeding the coagulants, etc. That is dry feeding and wet feeding. So we discussed that part. Today we'll be discussing what is meant by mixing. So what do you mean by mixing? So the mixing, after the coagulant is fed into the water, we have to mix the coagulant so that it will be effective in forming the flocks. So the mixing process actually mingles the coagulants with the water, and it has a very great effect upon the formation of the flocks, and it is usual to introduce a chemical at some point of high turbulence in the water. So this process of mixing is usually done in tanks in which the water and the coagulants are mixed together, and such tanks we call it as the mixing basins. So what are the various types of mixing devices? So there are after the coagulant is added to the raw water, the mixing process is done by various methods. So some of the simple methods include firstly the centrifugal pump. So in most cases what they do is the centrifugal pump is usually used in order to lift the raw water to the settling tank. So then in this case the required dose of the coagulant will be added to the suction line of the pump, and when the water fed with the coagulant passes through the impeller of the centrifugal pump, there mixing will be accomplished by the agitation. And after the water comes out, some gentle agitation is again required to get good results and to accelerate the coagulation and the sedimentation process. Another method is by diffusing compressed air into the mixing basins from the bottom. So in this method, the raw water fed with the coagulant will be agitated by this compressed air that is diffused from the bottom of the mixing basins. Now coming to the types of mixing basins, broadly we can classify them into two types. Firstly, the mixing basin with the baffle wall, and then we have the second type, a mixing basin with mechanical devices. So mixing basin with a baffle wall means it consists of a number of baffles inside the basins. Again, the mixing basins with a baffle wall is further divided into two types. There are two types. Firstly, the baffle type basins, and then we have the mechanically agitated type basins, like I told you. And this mixing baffle type basins are further divided into two types: the round the end baffles, and we have the over and under baffles. So in the case of round the end baffles, the baffle walls are either provided in such a way as the water flows horizontally. Here you can see round the end baffles. So here the baffle wall are provided in such a way that the water will flow horizontally around the ends. So this is called as a horizontal flow type. And when it comes to over and under the baffles, here the water will move vertically over and under the baffles. So here we call it as a vertical flow type. And the disturbances that are created by the baffles in the path of the flow actually gives the required mixing. And normally the horizontal flow type is more preferred because it is more easy to clean this type of a basin. So this is a typical round the end baffle type mixing basin. So in this case, actually a rectangular tank is divided into continuous series of channels by means of baffles, and this causes the water to which the chemical has been added, that is a coagulant has been added, to flow around the ends of the baffles. There are as you see in the figure, there are numerous channels through which the water will flow, and the channels are made narrow so that the velocity of flow will be sufficient. So if water flows with high velocity, what happens? Then the settling will not be effective. So here the channels are made very narrow so that the velocity of flow will be sufficient to prevent the formation of the deposits. So in the case of basins with over and under baffles, like I said, the second type, the chemical mixed water will flow over and under the baffles through the channels. So that is a vertical type of a mixing basin. Now, coming to the next type, that is mixing basin with mechanical devices. So, mixing basin with mechanical devices or mechanically agitated mixing basins. Actually, these are those in which the water is subjected to a violent agitation when the chemical or the coagulant is first added, and then to a gentler action when the floc is formed. So, the first of these operations is usually achieved in mixers. So, here we call it as a flash mixer, and the second round it is in a flocculator. So we'll see what is a flash mixer and what are the flocculators. So here, as you see in the figure, this is a typical mixing basin with a flash mixer. So in a flash mixer, the rapid mixing is caused in rectangular chamber. So here you have a there is a revolution of the propeller that is fixed to a propeller shaft, and this is driven by an electric motor. So the flash mixer is designed so that the displacement capacity of the impeller is greater than the maximum flow through the chamber, so that the alum solution, that is a coagulant, alum is the coagulant, suppose if alum is used as a coagulant, the alum solution and the water will be folded together, and there will be a quick mix of this, and consequently the alum consumption is held to the necessary optimum for adequate treatment. So here, like you see here this figure, the detention period is there is a propeller at the impeller at the center. So it is this impeller which is the impeller which is a propeller type, right? And this is commonly employed in the flash mixers, and they have very high revolving speeds which ranges from 400 to 1400 revolutions per minute. Now here a detention time of say 30 to 60 seconds is provided in the flash mixer, and as this figure shows, the usual power requirement are from 1 to 3 watts per meter cube per hour of flow. So you can see the various parts of a flash mixer. There will be an inlet for the raw water, then you have a deflecting wall here through which the water will pass, then you have this impeller which is a propeller type impeller, and then there is a shaft which connects the impeller, and then the water will be coagulant will be pumped, or there is a pipe from which the coagulant is fed into the flash mixer. So after this mixing is effected, what happens is there is an outlet through which the water will flow into the flocculator. So this is a typical mixing basin with a flash mixer. Now coming to the various design criteria of a mixing basin with a baffle wall. So like I showed you earlier in the figure, this is a typical mixing basin with a baffle wall. This is a round the end type of a baffle wall. So here the various design criteria here. Firstly, the velocity of flow in the channel between the baffles is usually between 0.15 to 0.45 meters per second, and the detention time is, that is the detention means the time for which the water is detained in the tank, it is usually 20 to 50 minutes, and the distance between the baffles should not be less than 45 centimeters. So here you can see it is marked as X, the distance between the two baffles. It should not be less than 45 centimeters. Again, the clear opening between the end of each baffle and the tank wall. So this is shown by the distance Y here. The vertical distance Y, that is the distance between the end of the baffle and the wall of the tank. It should be kept of 1.5 times the distance between the baffles. So Y should be 1.5 times the distance between the baffles, that is X. And the floor of the channel should slope towards the outlet. Of course, only then the water will flow from the outlet. Now, for around the baffle type, the depth obtained by dividing the cross-sectional area of each channel by distance. Depth is obtained by dividing the cross-sectional area of each channel by the distance between the baffles. Now, so these are the design criteria. And also for around the baffles, the depth should not be less than 1 meter, and the width of over and under the baffles will be obtained by dividing the cross-sectional area of each channel by the spacing between the baffles. The effective depth of flow is usually kept 2 to 3 times the distance between the baffles. So these are the design criteria. So like you see here, the width of the over and under baffles is obtained by dividing the cross-sectional area of each channel by the spacing of the baffles, and the effective depth, that is the depth of flow, is kept 2 to 3 times the distance between the baffles. Now coming to the mixing basin with mechanical devices, here the impeller speed is kept between 100 to, that is the design criteria in the case of a flash mixer. The impeller speed is kept between 100 to 120 revolutions per minute, and the detention period is 0.5 to 2 minutes, and the power required for flash mixing is 2 to 5 kilowatt per meter cube per minute. Now coming to the next type, that is flocculation. So flocculation is again stimulated by the mechanical means to agglomerate the destabilized particles into compact, fast settleable particles. So after the coagulant is added and it is mixed in a flash mixer, the next, like you see in the figure, from here the flash mixer, it goes to the flocculator. So what is a flocculator? Flocculator is actually a device in which the particles, that is, it is here what happens is it is actually the mechanical means to agglomerate the destabilized particles, and this will form compact and fast settleable particles or flocks, which can be collected at the bottom of the sedimentation tank. And flocculation or gentle agitation results from velocity differences or gradients in the coagulated water, which causes the fine moving destabilized particles to come into contact and become large readily settleable flocks. So here this figure shows a typical flocculator which is fitted with the paddles. So it is an operation that is designed to force the agitation in the fluid and to induce the coagulation process. And basically the flocculation, it is actually a slow mixing or agitating process, and slow mixing is the hydrodynamic process which results in the formation of large and readily settleable flocks. And as you see in the figure, a typical flocculator, it consists of the following parts. So it consists of a rectangular tank for slow and gentle stirring to permit build-up and agglomeration of the flock particles. And also these, as you see here, the rectangular tanks are fitted with paddles which are operated by electric motors, or plain sedimentation tank with controlled flow velocities are also used as flocculators. Now coming to the different types of flocculation. So there are 4 types: the perikinetic flocculation, orthokinetic flocculation, gravitational flocculation, and the mechanical flocculation. So perikinetic flocculation means here flocculation is due to the Brownian motion of the colloidal particles, and the random motion of the colloidal particles results from their rapid and random bombardment by the molecules of the fluid. And orthokinetic flocculation means here the contacts or collisions of the colloidal particles resulting from a bulk fluid motion, such as stirring. So when you stir, what happens? There will be collision of the colloidal particles, and thus it forms flocks. So this is what happens in orthokinetic flocculation. Then we have the gravitational flocculation, wherein the water will flow by gravity and the baffles are provided in the basins, which induce the required velocity gradients for achieving the formation of the flock. An example for that is the baffle type of a mixing. So this is a gravitational flocculation. Coming to mechanical flocculation, in this method the mechanical flocculators will consist of revolving paddles with horizontal or vertical shafts. Like I showed, the impeller and that the mechanical devices are used for producing the flocks. So this type of flocculation we call mechanical flocculation, wherein the mechanical flocculators will consist of paddles which will be revolving with the horizontal and vertical shafts, or the paddles are suspended from a horizontal oscillating beams that moves upwards and downwards, that is in a vertical motion. So these are the different types of flocculation. Thank you.